So many people. Good afternoon, RubyConf. I would like to start us off this afternoon with a few self-evident truths. And I don't want you to think at all for the first part of this talk. I want you to respond with pure emotion, all the rage, all the joy you can muster, pure lizard brain. Let's start with a nice, easy one. All right. What about this? Now you're warming up. Okay, let's knock it up a notch or two. Excellent, there we go. All right, what about this? Yeah. Fairly confident on that one. And last but not least, programmers love having strong opinions on topics. And before we move on, I would like to just say that all of those were completely wrong. My name is Andy Nicholson. I work at... Oh, breaking news, by the way. The Supreme Court, or the Appeals Court, has upheld the decision to stay the immigration ban, so that's pretty awesome, I think. But enough of him. I work at Cogent. We are also hiring, and all I will say about that is I don't believe that I will ever work at a better place in my entire career. That's a big call. If you want to know why, find me or any of my colleagues after any of the breaks, and we'll be happy to talk to you. I'm Andrew.Nick on most of the Twitter's things, and all flames can be sent to DevNull. So today we're going to talk about something quite controversial in the Ruby world, and that is types. And some of you might have heard the talk description and thought, no way. No way, I came to Ruby to get away from that noise. I never wanted to write public static void main again. Or you might have reached for your favorite Alan Kay quote and told me that he didn't have C++ in mind when he coined object orientation. And if that was your reaction when you read the talk description, relax. Look at the otters, it's going to be okay. I'm not here to tell you that I've seen the light. I'm not here to tell you that statically typing all the things is what you should do in all your programs. I'm not here to tell you that method missing is considered harmful, or that Ruby is blub. I'm not even here to tell you that objects are a poor person's closures. If you're a new Rubyist, and none of that made any sense at all, it's okay, welcome, don't worry. Software development can be a pretty tribal industry, but it doesn't have to be, and you can be part of the solution. Don't be like them. Now, if we're going to make any headway this afternoon about types and talking about them in a way that gives off more light than heat, we're going to need some definitions. So let's start with the font of all wisdom. Wikipedia says, a type system is a set of rules that assign a property called type to various constructs a computer program consists of, such as variables, expressions, functions, or modules. The main purpose of a type system is to reduce possibilities for bugs in computer programs by defining interfaces between different parts of a computer program and then checking that the parts have been connected in a consistent way. That's a long definition. For the purposes of this talk, a type is a piece of metadata. It encodes something we know about our code, or the data it operates on, into the code or the language itself. Any Haskellers worried that this definition precludes types being data may be at the wrong conference. We can use types to describe how much memory should be allocated for a piece of data. We can use them to describe how to interpret or encode the data that we have, whether we're allowed to change it or not, or even whether, as in Aaron's talk, we actually have the value itself or just the address of the value. Now, all of those examples were from C or C++ or PHP or Java or even Rust or even Pascal. What about Ruby? If you came to Ruby from a language like Java, you probably felt, as I did, an initial surge of freedom, as boilerplate you hated writing just seemed to melt away. And then a little bit later, this might have happened. But don't do that. And it was great. It felt really liberating, didn't it? Until one day, this happened. Now, those of us who've written code in Ruby for a little while will be able to guess what's happened fairly quickly. But I'm confident there was a point for all of us when this was a confusing error that didn't make a lot of sense at all. How can we do better than that without static types or compiling? We'll come back to that later. So Ruby does have types. They just might be a little bit harder to spot. I had to put an emoji in because emojis. One of the most common statements we like to use to describe Ruby is that everything is an object. Now that statement is itself a simple, simplistic type declaration. It means that every value can be asked questions and sent messages. It may not feel like a type declaration, but it matches our definition. It's just baked into the soul of Ruby, not a syntax. Okay, but apart from explaining how two.times do works, it doesn't appear on the surface to be that useful. Okay, well, we also, as Ruby programmers, make type declarations every time we make a method call. When we call foo.bar, we are asserting to the Ruby compiler that the object foo has the type response to bar. We just don't do anything with it and let it crash if it's false. And that's what we mean when we talk about duck typing. If an object walks like a duck, talks like a duck, sounds like a duck, it's probably a duck. And we can restate that in our typing language. So if an object responds to the methods we expect it to, it's probably the right type. Most of the time, this works pretty well. And as developers actively working on a system, we keep a large amount of knowledge in our heads anyway, so we're often able to remember what the correct methods and the types implicitly should be. And of course, there are trade-offs. Because of the way Ruby works, we can't know if the code is actually correct until we run it. Actually running and executing our code is the only way we can be confident that we've captured our thoughts correctly and accurately. This is one of the reasons we Rubyists bang on so much about testing, because without testing, we're flying blind. And yet still, a lot, maybe even most of the time, this works quite well. As we use TDD and let our tests set out the design blueprint for our code's behavior, we end up with nice, flexible, well thought out code that's easy to change. Sometimes. Consider this code. I liked Marcos's definition of slide code yesterday. We're going to go with that, slide code. We have a few methods here. We have a print items method that takes a collection and does something to that collection for each item. We convert it to a string, the code to a string, and bring it to the console. And we have another method called process report that accepts some data and, among other things, just calls print items on that data. What happens when we do this? It explodes. We get an error from Ruby saying that there was an undefined method upcase for nil. Yuck. Okay, that's not so bad. We realized that the item was expecting to have a code and it didn't have one, so it got returned nil, and there's no upcase method on nil, and so we got an error. So we'll make a a small change to use the fetch method instead. And now, if we make the same mistake, we get a much better error. We find that there's no key called code in that particular hash. Okay, great. So a little bit later in our project, we make another mistake, and we call this process report method with an empty array. Well, an array of arrays. And now we get this. No implicit conversion of symbol into integer. What? And this is where duck typing has unfortunately let us down. We passed an array which responds to the fetch method the same way that a hash responds to the fetch method, but they don't do the same thing. It wasn't a hash duck, it was an array duck. Turns out that array fetch is looking to find an entry by an integer index, not by a key, and so it tries to coerce whatever you passed it into an integer, and you can't coerce a symbol to an integer explosions. If you've ever had to debug a square bracket access on an array, when the code was thought it was sending a message to a hash, you've seen this error before. Don't do that either. So let's make another small change. Before we do anything with the items in the collection, let's just turn them into a hash using the hash coercion operator that Ruby provides. And now, if we make a bunch of mistakes, we get sane errors for all of them. I don't know if we can see them with the contrast. If we pass in a collection of an empty array, we get the key not found error, which is the same for an empty hash. The reason that they're the same in this case is because an empty array coerces to an empty hash. But if we pass something in that completely doesn't make sense, we actually get a useful error. You can't convert an array like that into a hash. The benefit of using that hash coercion operator, and Piotr Solnika in his talk yesterday touched on this briefly, is that anything that knows how to be coerced into a hash can be passed to this method and it will work. We had a plant class that has two hash defined on it. We can pass that into our process report method and that will work just fine. If you're curious about any of this sort of thing, Avdi Grimm in his excellent book Confident Ruby spends a fair bit of time talking about the explicit and implicit ways that data can be coerced in Ruby. And I found it a particularly great way to get more confidence about the data coming in and out of my methods. You can also look at contracts.ruby, which has been around for quite a while, a way of implementing type signatures of a sort in front of methods. And there's also the dry types method from dry-rb, and we've heard a bit about that already. What other things could we think about from a typing perspective? What about code execution? Say you've got some Ruby code that needs to do a bunch of operations in a certain order. And if there's a breakage, you want to stop, handle the errors properly, and return some result. You've probably written code like this. I know I have, and not just for this slide. So this doesn't handle errors at all. So we might go, okay, I need to handle errors in my code, and so I'll do this. I'll have a begin, rescue, end block, and I'll rescue from all my errors and handle them. But then if any of these operations might return the same amount of the same error, we might need to capture the result from each of them sequentially. That doesn't look very good. There's got to be something better than that. What if instead our code could look like this? The code looks much more like we want it to read. We're going to do an operation that might fail, and then another one, and then another one in that order. And if that chain of operations succeeded, then we can return the value from that. If something blew up, we can re-raise that exception or log it or whatever. And if this looks a little bit like the result type that Rahul was showing us in the Elm talk just before, that's not an accident. This is actually an implementation of basically that exact type from the dry monads gem, which is an unfortunate name because if you're anything like me, you see monads in a gem name and you run a mile. But it doesn't look like there's any types here, does it? Apart from that weird try thing at the beginning. But let's break down what this is actually doing. That try operator at the beginning takes a block. That block either succeeds, which means it doesn't raise an exception, or it fails. And that, if it succeeds, the result is wrapped in a success object, which is then passed into the next bind method, the next block, and so on, all the way down the chain. If it fails, the failure is wrapped up in a failure object, and that failure object is also passed down the chain. Both the success and the failure objects respond to bind, they just do different things with it. So if the operation succeeded, and you get a success object, and you call bind on success, you can just pass another block in, and the value for that previous operation gets bound to result in that block, and on you go. If you get a failure, and you call bind on it, it just ignores it. It throws the result away and returns itself. I presume it should do that. And that's safe. You don't need to worry about something going wrong in between or ending up with something half-baked. And you can catch the error that happened and do something with it. Now, I'm pretty new to this way of thinking. I'm not an expert at this by any means. I'm very new to type languages. I looked at a Haskell book once. I have a couple of OCaml books on my desk, and I've enjoyed dabbling with Elm quite a lot. But I've found that thinking about types in this way helped me to think more clearly about what I was actually trying to achieve, and it didn't ruin my Ruby code at all. I didn't magically turn my Ruby code back into Java. I didn't necessarily even need to change the way that the code looked. I just needed to think in a slightly different way. So what? You could use this kind of type thinking in a bunch of different ways. I haven't tried them yet, but you could use this to model state machines or other series of asynchronous operations, a whole bunch of different things. And I'd love to talk to you more about ideas that you might have on how you could use types in your code. Intuitively, we kind of already get that there are different ways to do things, and that ideas can flow backwards and forwards between paradigms and languages. We know that MRI, the standard C implementation of Ruby, has drawbacks when it comes to concurrency. So we've taken the developer experience of Ruby's pleasant syntax to the Erlang VM and given the world Elixir. You might have heard of it. But as Marcos so vividly showed us yesterday, we don't have to do that. There are ways to use concurrency models like actors in Ruby, and there have been for some time. It's not either or. You don't have to throw Ruby away just to get something that it might be not so good at. Again, more recently, some smart developers from Argentina wondered what Ruby would look like if it completely embraced the type system and compiled to native code. And so now we have the Crystal language as well. And Crystal is a worthy language if you're prepared to lose some of the dynamism that makes Ruby so fun to use. But being more thoughtful about types in your code doesn't have to mean ditching languages. Rails showed the world how easy it could be to get up and running on a full-stack web application and the benefits of good tooling. Sprockets, for its time, was a fantastic piece of software for the asset pipeline, and it's inspired the JS community to support a truly dizzying amount of front-end technology, including Elm. Ruby as a language and as a community has always embraced diversity of expression. We disagree with the Pythoneers or Pythonistas, whichever is correct, when they say there should be one and preferably only one obvious way to do it. Giles Bokert, a Rubyist, in a long blog post about something else, came up with this beautiful statement, Ruby is wa. He says, Ruby took disparate elements from Perl, Python, Lisp and Smalltalk and combined them in a harmonious blend. This artful blend of disparate paradigms is not a fluke. It's just the most recent step in a Japanese tradition which stretches back at least 1,000 years. Hopefully, some of the other talks here have inspired you to take a look at some languages like Elixir, Crystal or Elm. Have a chat to a random attendee about Elixir. They've probably tried it. Chat to Louis and Rahul or Kevin or Marcos and some of the guys or Seb about Elm, or to myself about Crystal. But as you do, be asking yourself, how can thinking about types make my Ruby code more fun, more structured, more stable, more of an adventure? Thank you very much.